Alhamdulillah, salatu wassalamu ala rasulillah. Chapter 11 is about matrices and determinants. We have 4 sections in this chapter. 3 of them will be about matrices, and the last one will be about the determinants of matrices. In the first section, we will study the relationship between matrices and linear systems. You know the linear systems from section 10.1, right? We studied there a linear system, a 2 by 2 linear system, when we have 2 equations and 2 variables. Today we will have more than that. We will generalize the idea to 3 by 3, 3 by 4, 4 by 4, and you can have, of course, n by n equations in variables. First of all, we will see what do we mean by matrices and what is the augmented matrix, special matrix of a linear system. What are the elementary row operations? What is the Gaussian elimination, the Gauss-Jordan elimination? And we will revisit the concept of inconsistent and dependent systems at the end. I think you know, most of you, they know the matrix, the concept of matrix. It is a mathematical object that represents indeed a combination of rows and columns of numbers. So you can think about the matrix like a rectangular array of numbers with m rows and n columns. These are rows and these are columns. Usually we specify the matrix by saying that it is m by n matrix. M indicates the number of the rows, n the numbers of the columns. And we call this m by n the dimension. So this matrix, it is of dimension m by n. The entries or the numbers inside the matrix, we call them entries. Also in some textbook, they call them elements of the matrix. The subscript here, ij, indicates the location of the number. So when we say aij, we mean the number that is in the ith row and the jth column. So this is for rows, this is for columns. Like here, for instance, A32, A sub 32, we shortly say A32. It is the element that is in the 3rd row and the 2nd column. Excellent. Now, this is a row, this is a matrix. What is the dimension of this matrix? It is what? 2 by 3. It is 2 by 3. And this one, 1 by 4. Now we will focus more on matrices in 11.2 and 11.3. Here in 11.1, it is all about linear systems. So it is only about augmented matrix. What is the augmented matrix of a linear system? When we mention the augmented matrix, it is related to the linear system, to a linear system. What is the augmented matrix? First of all, let's take a linear system. Is this a linear system? Is it linear? Each equation is linear. So what we are talking about today is just for linear systems, not for 10.4 nonlinear systems. Now this is a linear system. Now, if you just take the coefficients of x and write them in the 1st column, and the coefficients of y and write them in the 2nd column, here we don't have y, so it is 0. And write the coefficients of z, only the coefficients 1, -1, and 4 in the 3rd column. And then you wrote the constants 5, 0, and 11. You have what is called the augmented matrix. In some textbook, they separate by making a vertical line like here, like this here. So this is what is called the augmented matrix. It is the matrix of the coefficients and constants. You will just take the coefficients and the constant, but be careful. Be careful when you find the augmented matrix. You should make sure that all the x coefficients are under each other in one column, all the coefficients of y under column. So also you have to focus that the constants are on the right hand side. So for example, if we have here -5 equals to 0, this is not written in the standard form. So you will not write here 0. you will move the constant to the right-hand side and write here what? 5. So important. So you know now what is the augmented matrix. We will see later why we need it, for what we use it. Write the augmented matrix of this system. What to do to write this matrix here? You have here 6x, x, but you don't have here what? So you will get what? 6, 1, 0. For y, -2, 0, 7. For z, -1, 3, 1. For the constants, 4, 1, and 5. And this is the augmented matrix. Okay. Again, I will mention later why we use the augmented matrix and why we need it when we solve, of course, linear system. But let's mention also something that we will use in the next slides, the elementary row operations. What are the elementary row operations? We have only 3 in this course. We have only 3 elementary row operations. So do not use any other operations other than these 3. What is the first operation? Add a multiple of one row to another. What is that? Let's say that we have row number 1. A multiple of one row, for example, a multiple of row number 1, for example, 3. Multiplying row number 1 by 3 and add to another row, to row number 2, for example. So this is the first operation, adding a multiple of one row to another. What do you think now? The result will be written in which row? Which row now will be changed? What is the row that we will change if we did this operation? Is it row number 1 or row number 2 or row number 3? Row number 2. Add a multiple of one row to what? To another. And we will write the result in row number 2, not in row number 1. So this is the first operation. In general, we can say that this is K R J plus R I, for example. With I and J here, it specified the number of the row and write the result in RI. The second operation is what? Multiply a row by a non-zero constant. What is that? For example, row number 1 multiplied by -2. We multiply a row by a non-zero constant. Now the result will be written in which row? In row number 1. Row number 1 will be changed. Okay. The third operation is what? Interchange 2 rows. So you will just replace row number 1 by row number 2, or the opposite. So these are the 3 and only 3 elementary row operations that we have here. Let's revise them, ya shabab. What is this? Multiply row number J by K and then add the result to number I and write the total on RI. Multiply row number I by K and write the result in RI. Now interchange RI and RJ. Please, ya shabab, do not use other operations because they are not elementary row operations and they will lead you to a mistake. For example, we don't have this operation, row number 1 plus 3. There is no adding a number to a row. So this is not acceptable. Multiply row number 1 by row number 2. This is not an elementary row operation. So we don't have such operation like that. I'm afraid that I'm bring your kind attention to the errors and you focus on the errors. You remember this and forget what I told you to do. Please remember both, what to do and what not to do. Okay. So only three elementary row operations. Let's apply them here to solve this system. But before starting, I wanted to know why we need to use such elementary row operations and why we need what is called the augmented matrix. If I give you this system in 10.1, in section 10.1, what you will do to solve it? You will use elimination or substitution, right? But I think substitution here doesn't work. It will be so hard. So what you will do? Okay, what to do to apply the elimination? Now you will plan to use the elimination. What to do? Multiply. Multiply what? Add what? Give me one operation that you will do.
Add 0 to 1. Multiply the first one by 2.
Multiply the first one by 2. The first equation by 2. Why is that? For what?
Remove the y from the first one.
You want to eliminate y. Not bad, not bad. Good idea. But you can multiply the first equation by -1 and then add it to equation number 2. You will eliminate what? You will eliminate x. Multiply by -1 easier than multiply by -2. Okay. Also, you can multiply what? Row equation number 1 by what? By -3, then add it to equation number 3. In this case, you will eliminate x here, right? So, and then you will repeat that here. You will have 2 equations with y and z. You will eliminate y to obtain z. In fact, this operation can be done by using the elementary row operations and the help of the augmented matrix in a short way. So you can do that, but I don't advise you, please, do what we will do here. Use the augmented matrix. The idea is what? We will deal with the same system, but in a short way. We will not write x, y, and z. Just we will write the coefficients and the constants, the augmented matrix. Now, our target, ya shabab, is to do what? To apply the elementary row operations to have or to solve the linear system. It is better to have, of course, this one. We will see later, according to the Gaussian elimination, we need the first entry here to be 1. Why? Because it will be easy to multiply by 2, multiply by negative, if it is 1. Then we need this to be what? 0, and this to be 0. This is what we do to eliminate what? X. So what do you think? What is the elementary row operation that we can do here? Multiplying row number 1 by what? And add it to row number 2. By -1. Right? And the result will be written in row number 2. No need to write this, by the way. It should be clear that since I multiplied row number 1 by -1 and added to row number 2, so I will change row number 2, not row number 1. Then multiply, after you finish this operation, let's start this and see what will happen. So what we will do now, let me write it here. I don't want to write it above that immediately. So I will just say negative R1 plus R2. So you can do it mentally, but I advise you to write it to avoid mistakes. Right here above, -1, 1, -3, -4. What I did, I multiplied row number 1 by -1. Yes, Ahmed?
Why did you, sorry, continue.
Okay. Now what I will get? Now, row number 1 will be the same, Shabab. In the new matrix, row number 1 will be not changed. It will be the same. What we will change now, row number 2. The result will be written in row number 2. Now, what we will have here? 0, 3, -5, and 6, right? Then what? I can also use row number 1 to change row number 3. What to do? Multiply row number 1 by what? By -3 and add it to row number 2 and to row number 3. And the result will be written in row number 3. So what to do now? You can write it here again to avoid errors. You can do it mentally, but it is better, of course, to make sure about it. So this will be -3, 3, -9, -12. Now add it to row number 3. What you will get? 0, 2, -4, and 2, right? Now this is the new matrix. This is exactly what we have. Now say bye-bye for row number 1. Don't use it again. Because if you use row number 1 again, you will lose these zeros that you obtained. So you will redo what you did before. So don't use row number 1 anymore. Now your target now should be what? Now you eliminated X. Your target now is you need to eliminate what? Y. Now how to eliminate Y here? You need this. It is better if you have this 1 and this is 0. So if you can make this 1 and this is 0, it will be good. Or this is 1 and this is 0, it will be also good. Why? Because you after that you will multiply by a row and a number and it will be easier. I will show you next year, Ahmed. I will show you later. Now we are just doing this for the first example to investigate the need of what is called the row echelon form and the Gaussian elimination. I will show you in the next slides the process, what you should do to obtain this. Now, what we are trying to do now here, just to follow the idea that we learned in chapter 10, eliminate X, eliminate Y. So what to do here, the best thing to do here is to multiply the third row by what? By a half. Why? I make it 1 now, right? So now I can multiply it by what? By negative 3 and add it to row number 2. And this will make this what? 0. Look. Multiply the third row by negative 3 and add it to row number 2. We eliminate here what? Y. And what we get here, Shabab? From here, what we get? Z equals to 3. Of course, usually we prefer to have this order. So if we interchange, we can, of course, notice that all the operations that we are doing are from the 3 operations that we mentioned at the beginning. Always check, is the operation that you are doing is one of the 3 elementary row operations or not? Now, what I did here, in fact, just I want to have it in this echelon form, what is called the row echelon form. All the first leading entries are 1s, and all what is below them is 0. I can interchange row number 2 with row number 3. What is the problem? But if you want just to solve the system, it's okay. From here, you can find what is Z, and it is more clear here. By the way, here we were having the system, and we obtained the augmented matrix. Now, from the augmented matrix, you can have the system. Look. This is 0x plus 0y plus 1z equals to 3. So it is z equals to 3. This is y minus 2z equals to 1. Now you have z. Substitute here, you will get what? Y. Substitute here by z and y, you will get x. Notice that the first equation is still the same. We didn't change it at all. We didn't need to change row equation number 1. It's still the same. And this is equivalent process to the elimination method that we mentioned, of course, there. Now, what we will do, we will just try to make it formal as a guideline. You can always apply it to always, it works. What I'd like to mention here, Shabab, when you write the solution, it should be ordered triple. It should be X, Y, and Z. Be careful, because this is also a common mistake some of you are doing. Yes.
الحين اقدر اضرب باي رقم عادي اهم شيء خليها نفس الصوره هذه.
If you are doing one of these 3 operations, do whatever you want. You can multiply a row by any number other than 0. You can multiply a row by any number other than 0 and add it to any row and write the result in that row. You can interchange any 2 rows, and this the only 3 operations that we have. It will be more clear, Shabab, for you when we here mention the row echelon form. What we have here is called row echelon form. What is the row echelon form? A matrix is written in the row echelon form if what? Number 1, the first non-zero number in each row, reading from the left to the right, of course, is 1. What is that? Any number after zeros that is not 0, it should be 1. So now look here. What is the first number that is not 0? What is the first number here that is not 0? 1. What is the first number that here is not 0? 1. But here it is not. Look, what is the first number here after 0? It is 3. So this is not in the row echelon form. This is in the row echelon form. Clear? The second condition is what? By the way, we call this entry, the ones that we have there, we call them the leading entries. So this means that the leading entries should be what? Ones. 1, 1, 1, 1, 1. These are the leading entries. What is the leading entry? Is the number after the zeros. The second condition is what? The leading entry, which is the 1, in each row is to the right of the leading entry of the row above it, immediately above that row. What is that? Look here, that the one that is here in the second row, it is to the right, the one in the first row, right? Also in the third, it is to the right. So it is ordered this way. The third condition is all rows consisting entirely of zeros are at the bottom of the matrix. We didn't have this case here, but assume that we have here 0 and here 0. This should be at the bottom of the matrix, not in the second row, in the first row. Should be at the last row. This is what is called the row echelon form. Also, we have what is called the reduced row echelon form. What is it? It is the matrix that satisfies these three conditions in addition to this. Every number above and below each leading entry is what? 0. In fact, this means that these are the leading entries. Now we want the numbers above and below these entries to be what? Zeros. So we need also these to be zeros. Let me show you this in some examples here. Is this in the row echelon form or not? Why? Because what? Let's check the three conditions. Check the first condition. Is the first non-zero number is 1?
Yes. No.
Which one?
Yes.
Give me a number that is not after the 0, that is not 1. The first non-zero is 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 1. The first condition is satisfied. Now the second condition is the leading, each leading entry is to the right of the one above it. This is not. The one, it is on the left. The one in the second row is to the left, not to the right. So it doesn't satisfy the second condition. What about this? Every non-zero entry is 1, right? Which one? Give me a number after zeros that is not 1. The first non-zero entry is 1. The second condition, every one is to the right of the one above it.
No.
Give me one to the left or below. It is on the right. It is to not immediately. You mean it is not here. If it is here, it's okay. It will be better. But it is not here. This is the most important, that it is to the right. Now, this one, in fact, we have here a row consists entirely of zeros, and it is at the bottom of the matrix. So this is, in fact, in the row echelon form. And the last one here, it is, in fact, in the reduced row echelon form. Why? Because here, look, all the entries above are zeros, and all the entries below are what? Zeros. So this is what is called the reduced row echelon form. Again, we will use these later, ya shabab, to solve linear systems. The question is how to put a matrix in row echelon form. And this was the question of Ahmed at the beginning. Why you are doing this, and what is the order that we should follow when we solve or when we write a matrix in the row echelon form. The order is here. Step number 1, start by obtaining 1 in the top left corner here. The first entry in the first row should be what? 1. And then obtain zeros below that 1. Here, we need these to be what? Zeros. هذه هي step number 1. Next, obtain the leading 1 in the next row and the third row and the next row and so on until the end. And zeros below that 1. So you have here 1, you have below 0, and so on. Let me show you here an example. It is better to have a look here. So we need this to be 1 and this to be what? 0. Now, then you need this to be 1 and this to be 0. It's okay if you have this 1 and this 0, it's okay. You can interchange. Okay? But this is what you should have at the end. And then this one equals to 1. This is what is called, ya shabab, the row echelon form. And of course, if you use this technique, you are using what is called the Gaussian elimination. Using the row echelon form of the augmented matrix to solve a linear system is called the Gaussian elimination. And this is, of course, named after the German mathematician Gauss. Yes, Ali?
Can I move the order of rows freely?
Again?
Can I move the order of rows freely?
What do you mean by that?
Can I change the order of row 2 with the...
Yes, you can interchange.
Yeah.
This is one of the 3 operations that we mentioned. You can replace or interchange row number 1 with row number 2 and vice versa. Yes. Yes.
there a way to obtain the reduced score?
Yes, we will do that. We have an example about it. Now, how to solve a system by using the Gaussian elimination, or in other words, by using the row echelon form of the augmented matrix. Step number one, obtain the augmented matrix. You know how to obtain the augmented matrix. Step number two, obtain the row echelon form of that augmented matrix. Then substitute back, as you did in chapter 10. How to obtain the row echelon form? By using the 3 elementary row operations that I mentioned for you. Let's take an example. We need to solve this system by using the Gaussian elimination. How to do that? Step number one, the augmented matrix. This is step number one. Muhammad, please go and wash your face, please. Wake up. So now we need what? This is the step number one, the augmented matrix. Now we need this entry here to be what? 1. How to have that? Multiply row number 1 by 4, divide by 4. But try to avoid this mistake, this step, if you are going to have fractions, because this will complicate the problem. Remember that we will use row number 1 to change row number 2 and row number 3. So if you have fractions there, the process will be complicated. Are we going to have fractions here if we multiply by 4?
No.
So we are lucky, we can do that. Yes.
Can we multiply third row by 2 and add to?
Again, the process is to do this. I will show you. Start, use the first row to change row number 2 and row number 3, not the opposite. But if you have no option, you can do what you said. But after that, you will redo use number 1 to use change row number 2. So you may cancel what you did before. So this is the best process, but it is possible. As you are using the 3 operations that I told you, it's okay. So this is step number 1. Multiply the first row by 4. Next, we can do it at once, by the way. Multiply row number 1 by what? By -3 and add it to row number 2. The result will be written where? In row number 2. Also, after you finish this, multiply row number what? 1 by 2 and add the result to row number 3. Again, you can do it mentally, but I advise you to write it above just and then erase it. This is what we will have. Our next target will be having here what? 1. Remember that we need to have 1, 1, 1, and here 0, 0, 0, right? So now our target to have here 1, but it's okay if you can obtain here 0 before, it's okay. But we indeed, our target to have 1 here, it is to obtain 0 after that. What to do? Multiply the second row by half. No fractions, this is good. But even if you have a fraction at the last step, it is not a big deal. It will not cause a problem. So here we are, multiply the second row by half, we'll obtain 1 here. Now the last step is to have here what? Or the one before the last step. We need this to be what? 0. How to do that? Do not use ya shabab row number 1 again, because you will have here another one that is in place of the 0 that you have before. So do not use row number 1 just in the first step and say thank you after that to row number 1. Don't use it again. So we will use row number 2, just row number 2 multiplied by what? -5 plus row number 3. Here we are. Now you are done, by the way. If you are to want to solve the system, you are almost there. Why? Because from the last row, what we have? -10z equals to what? To 20, which is z equals to what? 20 over -10, which is -2. So you need to divide by what? -10. So multiply by 1 over -10. This is what is called the row echelon form. Now we obtain the row echelon form. Look, the first non-zero entries are 1s, and all the elements below them are 0s. Now, what is good that we have z? Clearly, z is -2. You can substitute in the second row to have y, and then in the first one to have x. You can write, by the way, it is better to write the system, get your system back. So if you use the elimination, you will get this at the end. Yes.
هل نقدر اطرح فوق بعض ولا بس
Yes, negative, multiply row number 1 by 2 plus row number 3. This can be written in row number 3, but not in row number 1, row number 2. This is wrong. So if you did this, if you want to change row number 2, what to do? Negative R3 plus R2. Now this is correct, but do not do that. Okay. Again, ask yourself, is this an operation from the 3 operations that we mentioned in that slide or not? Now what you will use, Shabab, the last step is the back substitution to obtain X, Y, and Z. Make sure that you are writing them in the right order. Now what we did now is called the Gaussian elimination using the row echelon form. You can also use what is called the Gauss-Jordan elimination. Do not use that unless you are asked to do, because you will do like 2 or 3 more operations. And Gordon, by the way, he also was a student for Gauss. So he improved his method by adding what? By eliminating also the numbers above the entries, not only the numbers below that entries. So what you will do, you will also make what is also above are zeros. And this is what we called before the reduced row echelon form. Let's apply it for the same example that we obtained in example number 3. This is the same system, example number 3. So we stopped at this stage, if you remember. What to do now? We need now this to be 0, this to be 0, this to be 0. How to do that? What are the operations that we need to use?
Use the third one.
Use the third one, exactly. We will use the third column to change the row number what? 2, right? And 1. You can do that. You can use row number 1 to eliminate this. Row number 3 to eliminate this to make it 0. Then you can use what? Use it to eliminate this also, right? And to eliminate this, you will use row number 2. So here we are. We will multiply the third row. We will use the third row. We will multiply the third row by -4, add it to row number 2. Multiply the first row by 1 and add it to row number 1. So just adding these 2 rows. Now to eliminate this, you will use the second row. Multiply the second row by -2 and then add the result to R1. Write the result in R1. And look here, what is good in the Gauss-Jordan elimination. We have X, we have Y, we have Z. So this is equivalent just to what we did before. So again, don't use it. It is in fact easier to use the substitution if you have it like that, unless you are asked to use it. The last part of this section, Shabab, is about the number of solutions, and we mentioned that in 10.1. Do you remember in 10.1 when I told you when you have A, Z equals to B, when we have no solution? If A is what?
0.
And 0, and B is not 0, right? So in fact, here we have no solution and we call the system inconsistent. If we have in the row echelon form a row that contains an equation like this, 0 equals to C, where C here is not 0, similar to what I told you before. Okay, so if you have a row like here, for example, if you have here what? Number, you have here 0 and you have here number. In this case, it has no solution. We will see that in the next slide. Now, when we have one solution, Shabab, if we have A is not 0, right? So in fact, we have here all the coefficients are not 0. So the coefficient of X is not 0, the coefficient of Y, and so on. So in fact, if each variable in the row echelon form is a leading variable, what is that? It means that it corresponds to the leading entry, to the ones. So you will have 1, 1, 1, like here. Look. So in this case, each variable is a leading variable. It has its leading entry. In this case, we will have one solution. Of course, this is if your matrix is written in the row echelon form. The last case, if you remember, what is it? Infinitely many. If what? If A is 0 and what? B is 0. So this is the case when we have one row consists entirely of what? Of zeros. If all the entries are zeros. In other words, that no variable is a leading variable. All of them are not leading variables. This is the case we will have here, like this. What do you think here? What is the case that we have here? If this is the augmented matrix of the system after writing it in the row echelon form, look at the last result here. What does it say? It says 0z equals to what? Possible?
No.
So this system has no solution, and we call such system inconsistent. Now, what about this? Every variable is a leading variable, and we have here at the end 1z equals to 8. Possible, why not? Even if we have, of course, here 0, it's okay. If you have 1z equals to 0, z equals to what? 0, no problem. Okay, the problem if you have here 0 and here 1, this is not acceptable. Okay, now, so this is a system with one solution, and we call it, by the way, just to distinguish between it and between the others, we will call it independent. Each variable is a leading variable. The last one, we have here a row consists entirely of zeros, and we have, of course, here infinitely many solutions, and the system called dependent. Here we have z that is not a leading variable. It lost its 1. No coefficient for z here, so it is not a leading variable. What do you think this system is? You will write the augmented matrix. Now you need this to be 1, it is 1. You need now this to be what? 0, and this to be 0. So what is the operation that you will use? Negative 2 R1 plus R2 and negative R1 plus R3. Here they are, ya shabab. Please, if you have a quiz or exam, specify what is the operation that you used. Now what you need, this is 1. You need this to be what? 0. So what to do? Multiply by row number 2 by negative 1, and then add the result to row number 3. Okay. Now look here what we have. Just to make sure that you have, of course, in the row echelon form, you can multiply the third column or the third row by what? The third row by 1 over 18 to have it in the row echelon form. If each entry is 1 leading entry. Now we have here, of course, 0z equals to 1, 0 equals to 1, impossible. And this is, of course, false. It has no solution. The system is inconsistent. For this system, again, make sure that this is 0y plus 0y, no coefficient here for y. And you have this augmented matrix. Again, what to do? We will take the attendance. Yes, what to do, ya shabab? We need this to be what? 1. So we will multiply by? We will multiply by negative third. But look what will happen here. You will have fraction here and another fraction here. And remember that you need row number 1 to change row number 2 and row number 3. So this will cause a lot of problems and calculations here. So remember that you have 3 operations, 3 elementary row operations. What you can do here? Interchange row number 3 with row number. So this is what you should do, not the dividing or multiplying by negative 3. So this is step number 1, just interchange. You have now the first entry is 1. Now what you can do? Row number 1 plus row number, this will change row number 2. Then 3, row number 1 plus row number 3 will change row number 3. Clear? Here we are. Then you need this to be 1, it is 1. Now you need this to be 0. You multiply row number 2 by what? By 2, then add it to row number 3. What we obtain, ya shabab? Infinitely many solutions, because we obtain here all consist of zeros. But the question is, what is the form of these infinitely many solutions? How to find it? You said there are infinitely many solutions. What I told you to solve the system. You are saying there are infinitely many solutions. What is the form of these infinitely many solutions? You need to specify the form. So what to do here? We have z here free. Z is free. So you can say z equals to any real number. But y and x, they are not free. They depend on z. So to find them, what you need to do? I think from here we can find it. This is clear, right? From here we have y minus 3z equals to 1. So you will have y equals to 3t plus 1, and z is t. But for this one, to make it easier, what you can do, you can multiply the second row by -1 and add it to row number 1. Why we did that? Just to have here y in terms of z, also here x in terms of z. This is, of course, just if you want to find the form of the solutions. Look, this is x, this is y. And the solution, the form of the infinitely many solutions will be like this. T, and this is y, 3t plus 1, and this is x, 7t minus 5. Now you can choose t to be any real number, and y will result from that value that you will choose. For example, if t is 1, you have this solution, 2 and 4 and 1. So this is one of the infinitely many solutions. What about this system? By the way, this system has what? If you notice, we have 4 variables in 3 equations. So it is expected to have what? Again? You mean infinitely many? It is expected to have infinitely many solutions. Why? If you have, for example, this easy example, look, x plus y equals to 1. How many variables? How many equations? So how many solutions? How many values of x and y satisfy this equation? Infinitely many. Y equals to 1 minus x. All the points on this line, in which they are in fact t and 1 minus t. For any t here is any real number, are all the points on this line. So it has infinitely many. So it is expected. To show that, write the augmented matrix. What you will do next, you need to find the form. In fact, we know that there are infinitely many, but what is the form of these infinitely many solutions? What to do? Negative row 1, negative R1 plus R2, negative 2R1 plus R3, then 2R1 or 2R2, 2R2 plus R3. Look what we have. We have this at the end. So infinitely many solutions. Now the question is, what is the form of these infinitely many solutions? What they are? We have here, by the way, an independent variable. Y. Y equals to what? 5. So it doesn't depend on any variable. Y is 5. But here we have 2. Now this is, of course, 5. This is done because this will be 2 multiplied by 5. Now we have here 2 variables that they are free and x depend on them. Of course, here we can eliminate one. Look, here we eliminate y there just to make it more easier. Now here we have y equals to 5, and we have z, x equals to 3z plus 4. If you consider z to be s, where s here is any real number, and w to be t, with t is any real number, then you have this form of the solutions. You can write the final, did he wrote it, and as an ordered. You can write it as an ordered, like what? 3s plus 4t and 5 and s and t. This is the solution of this system. Again, we have y equals to 5 here, y equals to 5 from here, and this is, of course, just to eliminate y here. No, it is not necessary. You can do it without that, because if you obtain y equals to 5, it is just to obtain this in a shorter way, but you can find it without it. I want you, Shabab, to solve this old exam question, because you need to practice. Did you understood what we did today? I'd like to check that you understood this. So please solve this system. Write it down now, because I will show you also the results of the last quiz and take the attendance as well. Who was absent, ya Shabab, in the quiz? We have 2 students were absent. Yes, good. So they are here. Okay, please write the system, ya Shabab, because I will move to the next slide. Okay, let me distribute and pause recording. So we have infinitely many solutions. In fact, what you will do, you will multiply row number 1 by 2 or by -2, then add it to row number 2, and multiply row number 1 by -1, add it to row number 3, you will get this. Notice here that the third row and the second row are the same. So now if you multiply the second row by -1 and add it to row number 3, you will get the last rho is 0. طبعا he didn't ask here about what is the form of them. But if he asked about that, you can find it, because here z is free and y and x depend on that. Okay, thank you, Shabab, and see you inshallah next Thursday.